Hello, today I'm going to be talking about coding maybe your first experiment in Psychopy and how that works with using the builder and a little bit of your own inserted code. Now, I've only been using Psychopy for a little bit less than a week, so I definitely do not know everything there is to know, but hopefully I know enough to show you something that you didn't know. So to get started here, I'm going to type Psychopy version just to make sure we're all working with the same version here. So I have Psychopy 2 version 1.85.3, and with that let's get the main thing opened up. I'll just type Psychopy here in the terminal. I like reading the tips at the startup. Some of them are helpful and some of them are funny. So yeah, give those a read. And I do not want to look at the coder, so I want to look at the builder view. There we go. So the first thing I'm going to do, I'm going to just close out of that coder there, and we are going to save this as an experiment. So I'm already saving in the correct folder that I want to, the assignment tutorial folder, and I'm just going to say assignment underscore task. So I'm just going to call this assignment task. And the assignment task, in case you don't know, is a task where you're presented with two stimuli, in my case an X or an O, and each stimulus is associated with a certain key press. So if an X is always associated with the right key press, and an O is always associated with a left key press. So the interesting thing that we can do is that we can present an X, which is associated with a right key press, on the left-hand side of the screen. So that promotes an inherent incongruency between what you see and what you have to press. And people are slower at doing that than pressing, than their reaction time for seeing an X on the right-hand side of the screen versus the left. Alright, so back to the Psychopy builder. What we have here is that the default name for a routine is called a trial. And the first thing that we're going to do in the builder is rename this trial to, I'm going to call it the assignment trial or the assignment stimulus. I'm just going to call it the assignment trial, just so we know. Okay. And this is going to be a graphical representation of the flow of the experiment, and this is going to be a graphical representation of this particular trial. The first thing we're going to do is that we need to add some stimuli. So we're going to add a text, and the first thing that we need in the text is a fixation cross. As a fixation cross, we want it to start at the very beginning of the trial. It's going to last 1 second, that's fine. And we want it at the very center of the screen. That's what 00 stands for. And for the text, we're just going to have a little plus. There we go, easy. Now we're going to make another little text object, and this one's going to be called left stim. So this is going to be the left stimulus. This is also going to appear right at the beginning and going to last the same amount of time as the fixation cross. And with the left, how this coordinate system works, for the units that we're using normalized units. So the x-axis goes from -1 to 1, and the y-axis goes from -1 to 1, because it's all normalized. And you can change that in preferences, which I can show after this. So with left stim, we want it over here, so that's going to be -0.5. And we're going to call that left stim text. So what this $sign represents is that instead of placing, say like the actual text to the Python script that gets built, we're passing a variable in. So the benefit of a variable is that it can change each time that this trial runs, which will become useful as soon as we add a loop, which we'll go into in a bit too. So we want this to be set every time this trial is called, so we're going to change it to set every repeat, okay? Okay. And then with that normalized units that I was talking about earlier, we can go to Preferences, click on the button, Preferences, and under Units, it's default under Norm. If you want to have more precise control over how your stimuli are organized, you can choose centimeters, pixels, height, degrees, and other variables, but for our purposes today, we're just going to use Norm for normalized. And let's hit OK for that. Now we'll add another text box for right stim. Again, start time at 0, the duration is going to be 1 second, and we're going to pass in another variable, right stim text. Alright, and then again, we want this to be set at every repeat. Okay, and then finally, for the text, we're going to add in a little ITI, and the start time, we're just going to hard code it here at 1 second, so it's going to start immediately after everything else finishes, and the duration is also going to be 1 second. And for the ITI, I'm just going to put another plus sign there, and that could be constant. Alright, so now we have all the text that we need, and how is the person supposed to respond? Because now they're just going to see X's, No's, but they don't know how to respond yet. So now we need to add a response object. And what we're going to do today is that we're just going to use a keyboard. So the allowed keys that we want are just going to be Z and M. There we go. And instead of key response 2, I'm just going to rename it to response. Doesn't need to be anything fancy. And we're going to start it at 0.2 seconds. Because anything faster than that, I don't think they have actually saw the stimulus and responded to it. And the stop is going to be, we're just going to have it be the duration, and we'll have them be able to respond for 1.8 seconds. So they'll be able to respond all the way up until the beginning of the next trial. And the allowed keys are always going to remain the same, so those are going to be constant. I do want to unclick this, because this will end the trial prematurely. So again, if this is clicked, then as soon as if I'm going through the task, and if I press a Z or an M, it'll stop the trial right there. So if I press a key at 0.6 seconds, it won't show the rest of it won't go for the remaining time for the left stem, right stem, and fixation cross, and it won't show the ITI at all. So for my purposes, I could probably code that so the ITI always showed, but for my purposes today, we're just going to unclick this, so that even if we press a Z, say right here, it'll still go through the entire trial. And then store correct. I like to know whether my answer is correct or not. And again, we're going to pass this in a variable which we're going to fill in later, and we're just going to call it ans for answer. Boom. Okay, nice. So this is going to be our basic experimental setup, where we see a fixation cross. There's going to be a left stimulus, a right stimulus, an ITI that happens afterwards, and then a response period in which you can respond at any point within the trial. So now let's get a view of that and a little bit of intuition on how that relates to the code. We're going to, well, first save this, just to make sure we got our progress, and then we're going to compile the script. Alright, and then we're going to save this Python script too so that we can view it. They have a decent viewer here, but I'm partial to Atom. It has a cool interface. So we can click on the Simon task here. Alright, so now I'll give you some intuition about, close out of that. Sure. Just give you some intuition about how the task is set up and how the stuff that you type in the GUI here relates to the code in here. So the very basic stuff that we're going to go through, if I can get this organized in a way. Alright, if I can get it actually working in a way. Okay, alright, fine. Let's have this like this. So when I clicked on experiment settings, right here, I see the experiment name, which is named Simon task, and that corresponds to this experiment name down here, which is represented as a string, as we can see by the quotation marks that surround it. String is a Python concept name, so if you want to look up what strings are and what you can do with strings in Python, you can Google that for yourself. Then the U here adds to interpret the string is Unicode, which is useful if you're not using a standard keyboard keys. Again, if you want to know more about that, the terms are Unicode and string. Okay, and then for experimental info, it has a field and a default, and how that's represented within this Python code is between these curly brackets, and these curly brackets are known as in Python as a dictionary. So again, I'm not going to go into the particulars of a dictionary, but all that you really need to know is that there are keys, such as participant and session are called keys, and then values are whatever comes after this colon here, right? So for the key participant, it's initialized to a default value of a null string. So there's no default value for that. And then for session, for the key session, the value is 001, which is what we see here, default 1. All right, nice. So all that makes sense to us. And then there's some more details about here for naming output files, setting up logging and experimental backgrounds, checking out the window, getting everything set up. All right. And here we are with our actual GUI again. Let me close out of this. And I guess this isn't so great. Okay, there we go. So we have a fixation cross, which corresponds to this. We display it on the main window. It's called a fixation cross. The text that we're presenting is the little plus, as we said, and the position is in the center of the screen. So we can see how all the variables line up between what we have in the Python script versus the GUI. And now what we have here, it's a little interesting. What they have for the text right now is the default text, right? But the position, everything is the same. So right now, instead of assigning the text to be the variable, they've set it to, I guess, a dummy placeholder called default text, right? And we'll see them replace that right here. So under the left stem and right stem objects that they made, these are the text objects, they set the text with the variable that we said as left stem text and right stem text. So they set those variables before we start the trial. And finally, when we start the trial, it asks us, yes, this is when we actually start the trial, and then while continue routine, and this routine timer is greater than 0, so it just essentially means as soon as we started the clock, and as soon as this variable, which is true or false, should be initialized as true right here. There we go. So while this remains true, and while time is greater than 0, so hopefully we're not going back in time, we will continue this trial, right? So then it initializes each object, the left stem object, the right stem object, so it actually displays it on the screen. And it'll eventually do the ITI after 1 second passes, so after the time is greater than 1 second. And the status is that it hasn't started yet. And then we'll also be waiting for a response, or actually recording a response after 0.2 seconds. And then we'll do some checking to make sure whether or not we should continue the trial or not. So essentially what Python will be doing with this while loop is iterating through the code that starts here and finishes here as fast as it can. So it'll keep going through all this code over and over again as quickly as it can until one of the conditions in the while becomes false. Since this will probably always be greater than 0, we're going to wait for a continue routine to turn false, and that will turn false where is it? Okay. So right now it says if not continue routine, so that means if one of the texts, if one of the objects up here is said to set continue routine to false, it'll break from the loop, or it'll break from the while loop. And then for each round of the loop, it'll also try to break out of the while loop by setting continue routine to false. But if the component, so all the Simon trial components represent all the text objects here, if the component is not finished, then the continue routine is true, and it'll keep continuing along the while loop. And what this break statement does is that it just breaks out of this little for loop right here. So as long as one of the components hasn't finished, it'll set continue routine to true, and then doesn't need to check any of the other text boxes because it knows that at least one of them is going to be true. Alright, so I'm sorry if that was a bit more in depth than you wanted, but that'll give us a nice intuition on how we will eventually add in our own code to make all this work. Okay. So I'll go back to the builder here. And what's going to be actually interesting is we just set up one trial right now, but we want to be able to do this multiple times. So we're going to insert a loop, and we're going to start it here. And we'll just call it trials. The default name is fine here. And for sake of time, we're just going to go through it twice. And the conditions is going to be an XLSX file or a CSV. As other people have said, you don't want the older version of the XLS file. Or a pickle. Nice. Okay. But today we're just going to use a CSV. Hit OK. And take a look at that CSV. This is all that it looks like. So we have a header here. So the first row is always going to be your headers. And that says condition and stem. So in the Simon task, again, the condition can either be incongruent or congruent, barring whether the X is associated with the right-handed press. Then the incongruent condition will mean that the X is presented on the left, and if the X is associated with the right-handed response, then in the congruent condition, the X will be presented on the right. And then similar philosophy for the O's. Okay. Boop boop. Peep that right there. So with this, we've loaded it in, and now we'll compile the script again to see how that changed things. So what we changed is that we added a loop and that we added a CSV file. So we're going to add that, save that, and then we're going to go back to here. All right, and this will update automatically. Now we're going to find that .csv file that we loaded in. Okay. And now we have a new object to work with called trials. And with the trial list, it does calls this object called data, and a method within that object, or a function, is if for those of you that might be more comfortable with that term. We import conditions, and then we import the conditions from this CSV file. And to give an intuition about what is contained within the CSV file, we are going to open up another terminal here, and we're actually going to call Python 2 and try to interpret what's going on when we do this import conditions. So I'm going to make this a little bit bigger. Well, maybe not that big, that big. So I'm going to type Python 2 into my terminal, and that's going to put me into the Python environment that the same Python environment that Psychopy loads into, Python 2. And I'm going to load the appropriate module, is what they say. So from the Psychopy module, I want to import data. All right. Oop, misspelled Psychopy. There we go. And then I'm going to go back to that CSV. Wait, going to, okay. Where I'm just going to copy this part, because that's the part that we care about, where the trial list is equal to import conditions with the string usimon task order.csv. And since I'm in the same directory that Psychopy was called in, I can just use the name and not specify the path name before this string. If I was in another directory, you need to specify either the relative or absolute path name. Alright, so now I can take a look at what trial list looks like. Alright, so now we got curly brackets and straight brackets. In Python, straight brackets mean we have a list, and the curly brackets, again, as I said before, mean a dictionary. So what we have in total is a list of dictionaries. So if I just wanted to access the very first dictionary in our list of dictionaries, I would access the first index by typing bracket 0 and bracket. And this gives me, again, a series of keys and values. So I have a key stem, which is equal to x in here. And then I'll pull this up so that we have a nice reference. And then a key condition, which corresponds to the value incongruent, which corresponds to this line right here. See? So stem is x, condition is incongruent, condition is incongruent. I can do the same thing for 1, so stem is x, condition congruent, so corresponds to there. And then I can do 2 and 3. And if I try to do 4, it'll give me an error saying that I'm out of bounds, because there isn't another line here that says what the condition stimulus should be. So yeah, you just have to understand or know that when we're coding in Python, everything starts at 0, and when you count in most other places that aren't computer science-y, they start at 1. Okay, so now we have an idea of how this trial list is represented and how we can use these values to help us code our experiment. So we're going to minimize these guys. We don't need the coder anymore. And we're going to go back to the builder. Alright, so now we've set up the loop. We have this set up. And now if we want to actually set up the variables for left stem text and right stem text, we are going to need to add another routine. We're going to say a new routine, and we're going to call this one the Simon setup, okay? And then we're going to put it within the loop since it needs to be set up each time the task occurs, or each time a trial occurs, because these variables are going to change. So we'll click on that terminal, or on that trial, and now we're presented with the same blank builder screen. We're going to make this a little bit bigger again, and we're going to click on the Custom tab, and we're going to insert some Python commands into our experiment. Okay, I think this is pretty funny. It thinks that the code is going to be a super big text, but then you just type it out and it's just itty bitty. Alright, so we're going to call this Simon setup. And we don't want it at the beginning of the experiment, we want it at the beginning of the routine, because then the values will actually change during each trial. So I'll click on this. I think that there's a little bug there where it doesn't actually highlight the begin routine, but it is actually, we're actually on that tab now. And I'm going to copy and paste this code that I made beforehand in to this. And this does what we wanted, and I'll talk through it right now. So I'll hit OK, if it'll let me hit OK. Maybe it won't let me hit OK. Okay. I'm going to try inserting this again. Click on the begin routine. I'm going to paste. I'm going to hit OK. Alright, there we go. Oh, wanted to rename it to Simon config. Alright. Nice. Alright, now we'll talk through what that code is doing. And it's going to use some of the concepts that it's going to use the concepts that we've already talked about. And there's one more thing that we need to change. So remember when I was talking about experimental info, there's participant and session, but now I have something called counterbalance. So that doesn't exist yet, so I need to make sure that exists in the experimental settings. So I can make that exist in the experimental info section here, and just hit, I can either hit a plus on either one of these, and I can just call it counterbalance. And what this is going to do for me is that it's going to let me know whether the X presses, or the X key should be associated with a right-handed press or a left-handed press, or in other words, the M key or Z key. Alright. And then I'm not going to have any default for that. We'll hit OK. Then we'll go back to the code so we can talk about that for a little bit. So with the experimental info, now that I've added a counterbalance key, and what this does by calling the variable experimental info, which is, again, a Python dictionary, you can access the value of a dictionary variable by specifying the key that you want to access that value. So for the counterbalance key, I want either the value to be either a 0 or a 1. Since it's always represented in text, I'm just going to say it's just the text 0 or the string 0 or the string 1. I could probably do better to be a more sanitary coder, but today we're just going to go with the easy example. So for the experimental info equal to the string 0, we have the bindings, which we don't actually use this variable. This is just for my own clarity right now, and if I wanted to code this more cleverly, but for today, again, we're just going to go for more clarity than cleverness. So for bindings, the X key is going to be associated with an M key press, so that's the value, and so a right-handed press, and then the O key is going to be associated with a Z key press, or left-handed press. Alright, so then if this trial, so where does this trial come from? That is something new. So again, we have the code here, we have the Simon trial, so we're going to compile this one more time, save it, go back, boom boom, go back. Now we're going to see what this trial corresponds to. So again, for this trial in trials, alright, so it's a part of the, it's each instance of trials. So trials must be a list. And we're just going to simplify this a little bit, and again call the trial list what we called it in the Python script before, but this is just going to be a list with extra parameters, including the trial list that we have. But let's just look at the trial list here. So again, with our trial list, we have a list of dictionary entries. So I can do for this trial, in trial list, I can just do a simple print statement where I say condition is dot format, and I want to access this trial, and I want to see what's the value of this key condition, right? And then I'll see if this works. Need another one of that. And again, it corresponds exactly to how we have it listed out here, where the first time it iterates, the first element is incongruent, second one's congruent, third one's incongruent, fourth one's congruent. Alright. So now we'll go back to Adam here, and we'll look back at the code insert. So this trial, again, is just going to be another dictionary variable in which we can access the keys, or we can use the keys as a reference to access the values. So if the condition is incongruent and the X is associated with the right-handed press, we're going to present the X on the left side of the screen. Now on the right-hand side of the screen, we're not going to show anything. And again, the answer, so remember when we saw this, answer is located, get back. So answer is located under the response, so that's the correct answer there. So we're actually going to be setting what the variable answer should be in the code right here. And that'll be happening at the beginning of each of the Simon trials. So the answer will always be changing. Alright. So again, we're just going to show the X on the left-hand side if it's incongruent, and then we won't show anything on the right-hand side because the trial is an X trial. Or if it's incongruent and the stimulus needs to be an O, if an O is associated with a left-handed key press, then we're going to show it up. We're going to show the O on the right-hand side and then make the left-hand side empty. And the answer is going to be Z, since an O is associated with the left-handed key press. And again, looking at this trial, if that is equal to congruent, if the condition is equal to congruent, then we check to see whether the stimulus is an X or an O, and we present the X, since it's congruent, on the same side, which is going to be the right. and have the key press also be the right-handed press. And then for the O, since an O is associated with the left press, then we're going to show the left stem text as the O, and the right stem text is again going to be empty, and the correct answer is going to be a left-handed key press. Then with our big overarching variable here, the counterbalance, it can also be equal to 1, and then when it's equal to 1, we can do the same stuff that we did up here, except all in reverse. So now an X is associated with the left-handed key press, and an O is associated with the right-handed key press. But otherwise, the code is the exact same as the top portion. Okay, so now we have that idea, we have the setup, we have the code written, right? And then again, if you want to know about if and elif structures in Python, I think there are many good tutorials out there. I'm not one of them. But this should have our experiment set up. Let me just check to make sure everything is set up how I want it to be. The left stem, set every repeat, that's good. Set every repeat, good. Constant, good. Correct answer, good. Response, good. All right. So now's the moment of truth in which we either get an error or the task starts running for us, and we can hit run. And then we'll get this little box up here. It'll let us know how to specify. So again, when I said counterbalance in the experimental settings, it added it here, so I can hit a 0 for the counterbalance. I can say test just for my participant. I can start the test. Oh, nope. So in module, counterbalance is not defined. So let's see, because I misspelled it here. Nice. Okay. So I'll hit that, save this, now I'll run. And I guess that goes to show I also like this, because the errors are usually pretty helpful. So I'll type counterbalance, I'll say 0 again, participant test, hit OK. That's an X. Oh no. Okay, I think I forgot to do another thing. X. Oh. Oh no. Okay. So that's the good thing about this, is that we can always figure out what we did wrong, so that wasn't showing the right place. Alright. So what was happening is that the right stem was just popping up in the middle and not where we expect it to be. So in order to fix that, again, setting up with the normalized stimuli, we need to set that up so it's on the right. Okay. Third time's the charm, right? Counterbalance 0. Participant test. So actually, one actually ran through. We're just going to call this the next session. That's M. Z, Z, M, Z, Z. Nice. No errors except for this warning, which for our purposes we don't need to worry about. Okay, and that actually created some data, which we will look at in another tab here. We created another folder called data, and for those of you that aren't very that are kind of command line phobic, we can check under assignment tutorial data, and these are all the files that we see in the command line. All right, so I'll do test assignment 141 11.csv. And it didn't record anything. Nothing is going right. Oh, that was because I opened the wrong one. That was the one that I didn't actually respond to. Okay. XG open test assignment 412.csv. Okay, so now this one should have actual responses that we can observe. Nice. And this one, I didn't actually press the keys. I just said that I was doing them, so the response keys are nothing, and so it says the correctness is nothing. And I put the session as 1. Which should not be correct. Okay, I'm going to have to pause it here to let you know what's going on. Okay, so I just ran through it again, and I actually responded with the keys, and we actually have responses, and they're all correct and represented with a 1, and we can have reaction times associated with them. Then the reaction time is actually measuring with respect to the start of the reaction time period. So in order to have an interpretable number, we would want to add 0.2 seconds to each of these values. So again, there's probably a better way to code the response time, but this is a way to get it basically working. So hopefully you're able to get some good information from this tutorial and be able to code your own experiments, and well as have fun with Psychopy. Alright, thank you for listening. Have a great day.